First ever Pulsar Summit. It's exciting. And our presentation is called The First Step Towards a Multi-AZ Architecture for Apache BookKeeper. My name is Anup Ghatage, and I currently work as a senior member of technical staff at Salesforce. Previously, I graduated from Carnegie Mellon University. I love databases, distributed systems, cloud computing. I worked at Cisco for a little while and then at SAP, and right now I'm at Salesforce.
Hello, everyone, and welcome to our talk about the first step to multi-AZ architecture for Apache BookKeeper. I'm Ankit. I work as a senior member of technical staff at Salesforce. Previously, I graduated from Carnegie Mellon University, where I specialize in cloud computing and distributed systems. So let's go ahead.
Cool. So the agenda for today is we understand that this is a Pulsar Summit. So we're just going to spend a little bit of time brushing up on the Bookkeeper basics so that you understand what we're doing. Next, we move on to explain why there is a need for a multi-AZ architecture altogether. We go over our design and eventually wrap up with what all it enables. So without further ado, a little bit of Bookkeeper basics.
In Bookkeeper, each unit of a log is an entry, and streams of log entries are called ledgers. I'll go over the terminology again. So entries contain the actual data that is written to ledgers along with some important metadata that we store in a central metadata server. Ledgers are the basic unit of storage in a Bookkeeper cluster, and they each are configured with some properties which include the ensemble size. The ensemble size is the striped size of the ledger across the number of bookies that are present in the Bookkeeper cluster. And there's the write quorum size, which is the number of minimum replicas we try to maintain for each entry in the ledger. And then there's the add quorum size, which is the minimum number of replicas or the number of entries that to be written to bookies before we can satisfy the client write request. That is, before we acknowledge the write back to the client. Bookkeeper follows the client-server model. So the client has two main roles here. They create and delete the ledgers, and they read and write entries to these ledgers that they create. And the servers are the bookies, which handle these ledgers. Bookies function as part of ensembles, which you mentioned. When bookies come up, they register themselves with the central metadata server, and they put a cookie in there, which we'll talk about in the next slide. In Bookkeeper, bookies are striped across the bookies. So each bookie might not have all the entries for a ledger. So over to you, Anup, for the cookies.
Right. So what is a cookie, right? If you were to ask me, I'd say chocolate chip, double chocolate chip. That's the kind of cookie I like. But in the Bookkeeper universe, a cookie means something else. In Bookkeepers, a cookie is basically an identity of a bookie within a cluster. It is created when the bookie is booted up for the first time, and it contains a whole bunch of information pertinent to that particular node, such as the bookie ID, the instance ID, where the ledgers are stored, where the logs are stored, etc. And it's not only an identity, but it is used to verify the membership of that particular bookie in that cluster. Not only that, but it also stores the state of the data on the bookie node itself and confirms if it is the same one which is stored in the metadata. So it is used for consistency of bookies across clusters. Now, that was on the server side, right? If we look at the client side, there is a concept called the placement policy. And the placement policy is used to control the placement of the entries of ledgers across entire ranges of bookies in a cluster. Currently, there are a few placement policies implemented, one of them being the region-aware ensemble placement policy and the rack-aware placement policy. I've spoken to a few folks in the Pulsar universe, and they mentioned that they currently use rack-aware placement policy kind of retrofitted to work as in cloud deployments, such that they say that one particular availability zone and all of its bookies are one rack, which isn't exactly true, but they kind of make it work. However, there is no native awareness or intelligence to handling this in a cloud-based deployment. It eventually comes down to the user that the user has to say that, hey, all of these bookies which are in this AZ are in rack A, and all of these are in rack B, etc. There's less automation and less intelligence for a cloud-based deployment in general. So we have to come up with a new placement policy, which is more cloud native and intelligent, and it can be more useful than what we have existing. So that kind of goes to say that why do we need this architecture, right? In order to be able to use all of these details in a much nicer way is one part of the problem. The second part of the problem are the native problems which we see in public cloud scenarios. So let's go over a few of them. Let's take a look at this article from Wired Magazine, which clearly states that AWS outages are basically also the responsibility of the designers of the software who utilize it to design for failures. That's interesting, right? Like, this tweet is personally my favorite. It basically says that the cloud is just a computer in Reston with a bad power supply. And it's not just AWS. There's also Microsoft Azure, which had to face 3 large outages in the last 12 months. Even the mighty Netflix was brought down to its knees by these outages during Christmas time, which is the most peak usage time. And to kind of circumvent that, they had to show pre-downloaded content of a fireplace being, a fireplace having logs burned, instead of showing that premium content, just because they weren't able to access all of the data in the cloud which they had. All of this goes to say that we should treat the cloud as a utility, and we should design for failures ourselves. This becomes even more important when we talk about Bookkeeper, because Bookkeeper is a source of truth for Apache Pulsar and many other upstream consumers.
So let's talk about how we go into the design. So the goals that we have here are being able to provide the same Bookkeeper API that we currently do to the client while honoring the same durability contract that the Bookkeeper currently provides, which is the system can tolerate at quorum size -1 number of failures without data loss. So in a multi-AZ deployment, we have to do this. We have to maintain enough copies among the bookies and to distribute them in such a way that the data is able to survive AZ +1 failures. That is an availability zone failure and an independent bookie failure. The obstacles to doing this in public cloud include, as Anup mentioned, the low reliability of cloud infrastructure, and it's prone to failures. And other problems that we often face are the cross-zone and region latencies, which are significantly higher unless you're talking in the same zone. The deployment complexity of a stateful application also provides a complexity there, which we have to work around. And the higher costs that are associated with cross-zone region traffic. And so multiple requests outside the same zone lead to a higher cost for the application. So let's go into the design that we did, and let's talk at a high level. So there are 3 steps to how we did this, to our approach. Step 1, we determined the network location of each bookie, that is where the bookie is present in the deployment, and we rely on the Kubernetes API to get this information. The second step is we store this location of the bookie so we don't have to retrieve it repeatedly from the Kubernetes API. This is useful and possible because the bookies don't change the locations once they come up. The location is fixed. And finally, the third step, we make this available to the client, which can use this for making decisions when reading or writing ledgers or creating ensembles. For example, a client located in a certain zone might not want to read an entry from a bookie in a different zone to prevent higher costs. So let's go into the step 1, the determining the network location of the bookie. So there are 2 ways we could approach this problem. We could get this information directly from the cloud substrate that the bookie is deployed on. So Amazon, GCP, and Azure all provide native APIs, which in form of REST endpoints, which you can directly query, and you can get the region and zone information for any pod or any node you have there. Or you could get this information from the orchestration system, which is used for the deployment here. So for example, in a Kubernetes-based deployment, the Kubernetes API retains all the region and zone information for all the nodes in the cluster. So the second approach offered us a couple of advantages, which we like. So it first of all, it allowed us to do this retrieval of the network location of the bookie in a cloud agnostic way. So if we went the first route using the cloud native cloud substrate APIs, then we would have to have specific code for S3, for AWS, for GCP. But Kubernetes has the same, like we can just use the same code always. The second advantage that it offered was the information can be directly fetched from the API from within the Kubernetes cluster without the need for any secrets. So you don't need an AWS secret key or a GCP secret key in there. So this, these advantages allow us, like, we just went to the second approach and we added this Kubernetes mapping class, which queries the Kubernetes API, gets the network location in the Bookkeeper code. Also, we added the concept of an upgrade domain, which we'll talk more about here.
Yeah, so this is the second step of the 3 steps Ankit mentioned previously. In the previous step, we got all the details from the Kubernetes API from various underlying substrates. We got details like the region and the availability zone. And then we did some extra processing on our side to understand something called the upgrade domain. And we persisted all of these details in the cookie. This makes it quite interesting because what happens is that the cookie is written to the metadata store, and hence all of these details are now available for the upper level placement policies from the client side, and they can take advantage of what the details are mentioned in the cookies about the zone information, etc. A little bit about the upgrade domain. So an upgrade domain is a concept, a logical concept or a logical grouping of bookies within a zone, which can be brought down together for upgrades and patching, etc., without having any impact to the upper level service. This is much more useful and reliable for most providers, since we constantly have to keep working with upgrades and patching for the storage system, and we can't afford any downtime. So this extra bit of information goes a long way to enable this particular aspect of always keeping the service up. Not only that, but we have these 2 layers now. We have the region and zone layer, and then we have the upgrade domain layer. This is a hierarchical structure which provides finer granularity to how a deployment is done within a particular zone or across zones. We store all of these details in the cookies, but we also provide some commands to be able to update and change these cookies in case of failure. Now we go on to the third step.
The third step is making this information that we retrieved previously from Kubernetes API available to the clients. So to do this, we added this mapping class called cookie-based mapping, which is capable of reading the cookies that we previously stored in the network location in from the metadata server and getting the network information out. So it reads this network location and it makes it available to any client or any code path we want to make use of. So an example of where this is useful is clients being able to read an entry from a bookie co-located in the same zone rather than going to a different zone. Because of the cookie, they can determine that this bookie is present in the same zone as them, and they can just use that to read that entry. Next, we go into what this multi-AZ architecture enables. Over to you, Anup.
Yeah. So one of the main features that it enables is the ZoneAware Ensemble placement policy. This is some part of the code which is actually already checked in by one of our teammates in the community code. So what ZoneAware placement policy enables is a whole bunch of things, right? As we previously said, the placement policy is a client-side concept which is used for distribution of ledgers across ensembles, across bookies. The ZoneAware placement policy is specifically designed for cloud-based deployments. It provides this hierarchical structure for placement of a ledger. First, we look at an ensemble, right? We want to understand which bookies are available in which zone in order to distribute the ledger across those bookies. The second level is within a zone. Within all the selected bookies, you want to be able to distribute them such that it is distributed across upgrade domains so that your data is persisted no matter if an upgrade domain is brought down for patching or upgrade purposes. So that way your service is always available and it is always up. This also enables some extra intelligence since the zone-aware placement policy is aware of the entire cluster. It's able to understand if certain bookies go up or down within a zone. It can keep track and understand and say that, hey, a whole bunch of bookies are down based on these watermark values. We should declare the zone to be down, or we should declare the zone to be up. Based on these particular details, we are able to utilize only fewer zones which are available and tolerate the zone failure. Addition of newer ledgers, etc., will be handled such that only 2 zones or 3 zones are in mind, or the zones which are up and not the zones which are down.
So let's talk about our takeaways here. What we implemented allows us to gather region, zone, and upgrade domain information for all of the bookies that are present in a bookkeeper cluster in a substrate agnostic way. And we serve it up to the clients and to the placement policies, which are designed to handle cloud failures. We thus end up with a bookkeeper cluster, which is a more like it honors the durability contract that is guaranteed by bookkeeper while being deployed in a public cloud environment. We provide intelligence to bookies. They function effectively in this deployment model. And the additions allow the bookies to be able to patch, upgrade, and restart bookkeeper clusters without impacting the consumers of the bookkeeper cluster that are dependent on it. So in a public cloud environment. We would like to take a moment to thank the rest of our team at Salesforce for their help.
And you can reach us at the given details. I'm on Twitter. Ankit is not on Twitter. He's too cool to be on Twitter. And you can always shoot us an email if you have more details or more details to discuss. So that's it from us. Thank you for your time. If we have any questions, we can take them now.
CG just sent a question. How do we handle removing a given zone?
I don't see it. How do we handle?
Removing a current zone, a given zone.
So removing an existing zone, in general, the zone information is persisted within the cookies for a bookie. So if we have to remove a particular zone, we remove all the details from the cookies such that the bookies are not considered going forward for any kind of placement, etc. So we have another question. It says, can you throw some more light on the Pulsar use case that was briefly touched upon? How does Pulsar provide rack awareness? I'm not entirely sure of how Pulsar handles this, but from brief conversations in the community, I understood that currently they map zones to racks, and there is a Pulsar tool which is used to map certain bookies to certain racks. So that way, given a zone is basically the entirety of a rack. And that's pretty much what I know. You can always post about this in the Pulsar Slack channel for more detail.
CG asked a question, do you use zone information for rolling upgrade? Yes, the upgrade domain coupled with the zone is the purpose behind the adding those things. The upgrade domain is the foundation for rolling upgrade. So you cluster bookies into these upgrade domains and you do a rolling upgrade across like upgrade domain. So you bring down a upgrade domain, you upgrade it, and then move on to the next one. Question, you said this work enables zone-aware Ensemble placement policy. How is it better for cloud deployments over existing rack-aware Ensemble placement policy?
Right. So as we mentioned, ZoneAware placement policy is designed with the cloud in mind. It provides a hierarchical approach. Not only does it segregate bookies according to zones, but even within zones, it provides a logical construct of upgrade domains, which can be brought down without impacting the higher level service, which wouldn't be available in rack-aware placement policy. Also, ZoneAware has this detailed it's able to understand whether a zone is up or down and then take decisions. You can find more details about this in the community code, which is contributed by Charan, one of our team members. There is
Question.
another question. Yeah, Ankit, give it.
What happens if the Kubernetes API fails to give the network information? So for this, what we did was, if the Kubernetes API does not return a valid network location on, the bookies are able to still join the cluster with a null network location. And using the bookie shell commands that like Anup mentioned, we can update the network location in the cookie later on. So Anup, do you want to talk more about that?
Yeah, so we provide a configurable option such that it's a strict boot up, wherein if you are starting a new cluster on a new AWS or Azure deployment, you want the network location to be there. So if you set the configuration option to strict, the bookies won't come up if it's not able to get the underlying Kubernetes information. We also provide a soft configuration option where it's able to come up with a null network location, as Ankit mentioned, and we can, in retrospect, fix it with the bookie shell commands which we provide. There are a few more questions. We'll go over them one by one. Is it all requisite code in open source, and is it publicly available for community use? Not entirely. There is the ZoneAware placement policy part of the code, which is currently available. We are working on contributing back the mappings which we discussed and the changes to the cookie format, etc.
There's another question. Which K8s API are we using? Are we using the zone annotations in persistent volumes? Not exactly. We are using the zone annotations for the nodes that the bookies are running on, that the bookies are being scheduled on. So we know like the volumes might retain the bookkeeper identity, but once the bookie is scheduled on a node, we just get that information.
Yeah. So there's another one. Do you have Jira numbers for outstanding contributions? Not yet. We are going to be working on it. We have a few parts contributed already. We'll be opening the BPs, as they call the bookkeeper proposals for these, and we'll share them in the community, of course.
Another question. How difficult is doing this in a non-Kubernetes environment? Unfortunately, we have not explored doing this in a non-Kubernetes environment. We currently rely on an orchestration framework such as Kubernetes, which is able to store the network, the region info for the nodes that are present in the cluster. But that is something we could definitely look into. Another question: how does this interplay with node or pod affinity policies in our Kubernetes cluster? So with a public cloud deployment model, we would like the bookie should not be scheduled, bookie pod should not ever be scheduled on the same node. So this would work with the anti-affinity policies that are present in stateful sets. We would try to schedule bookies in different zones and make sure that the bookie pods are always on different nodes to make sure to honor the durability guarantees and work with the AZ+1 failures.
All right, I think that's it with Q&A. If there are any other last minute questions, feel free to insert them now. Just a friendly reminder as well that we have a Slack channel that people can join if you guys want to continue to network or follow speakers there. You can do that at apache-pulsar.slack.com and look for the Summit channel. And thank you so much, Anup and Ankit. That was a very, very informative session.
Great. Thank you so much for having us.
Thank you so much for attending.
Thank you.